This is page 86 of your math journal. We're going to call this one function rules. Alright, a function rule describes the relationship between the input and the output. Describes the relationship between the input and output. Okay, so when we have a function rule, it's going to be an equation, and it's going to have your input and your output in it, and you're going to say what's happening. So let's start with this example. If we're given x and y, x is going to be our input, y is going to be our output. Let's see, we have these numbers: 1, 4, 2, 5, 3, 6, let's do 7, 10, and 10, 13. So looking at this, we're trying to figure out what's happening to x to get y. What's happening to the input? Let's write this here. What is happening to the input to get the output? Okay, if we look here, 1, we get 4. 2, we get 5. 3, we get 6. 7, we get 10, and 10, we get 13. So right here, I can see that this is 3 more than that. I can see that this one's 3 more than that. So how does the input compare to the output? Well, in this case, it looks like the input has been added to 3 to get my output. So here, this would be the function rule. I take whatever my x is, or my input, add 3 to it to get y. Alright, let's try another one. Okay, we're going to do x and y again. Let's do 1, 2. 2, 4, 3, 6. Let's get to 6, 6, 12, and 10, 20. So if we look at this one, what's happening to the input to get the output? Well, if I add here, that would be adding 1. This adds 2. This adds 3. Okay, so that's not doing... What am I doing to my input here to get my output? It doesn't look like I'm adding anything. So I'm going to write plus. Sorry, I'm not going to write that. So it's not adding. So let's look at what else it could be. What else do we have in math? It's going up. Well, I could times this by 2. That gets me 2. 2 times 2 gives me 4. 3 times 2 gives me 6. 6 times 2 gives me 12. 10 times 20 times 2 gives me 20. So it'd be x times 2. So in this case, it's timesing. So it's the input times 2 to get the output. want to show you another way we could have looked at that. See how much it changed from here to here? See how that went up 1? Well, 2 to 4, that went up 2. So it's changing twice as fast. Let's look right here. This went up by 1. This also went up by 2. This went up by 3. This one went up by 6. 6 is 2 times as much as 3. So that's another way you can look at it. Okay, let's skip 2 lines here, and let's write one right here, and let's do a different input and output. Let's do M and D. Okay, let's say my input is 1, my output is 7. Let's say my input is 2 and my output is 13. If I do 4, my output is 25. If I do 5, my output is 31. Alright, let's see if we can mathematically figure out what's going on here. So, we're going to do something to x. Oh, not x in this case. Sorry, this is going to be m, because my input is m. What am I going to do to m to get d? Okay, first of all, let's check and see if adding 1 plus 6 is 7. 2 plus 6 doesn't give me 13. 4 plus 6, no, so just adding isn't going to work. Okay, 1 times 7 gives me 7. 2 times 7 gives me 13. No, 4 times 7 doesn't give me 25. Okay, so timesing doesn't just work. Sometimes it's a combination of both multiplication and addition or subtraction. So let's see here. Let's look at how much it changes. From here to here, it changed 1. From 7 to 13, that changed 6. Let's look at here. Here it changed 2. From 13 to 25, that changed 12. From 4 to 5, that changed 1. From 25 to 31, that changed 6. Okay, this is where we can figure out if it's growing how many times faster. So looking here, 1 times 6 gives me 6. 2 times 6 gives me 12. 1 times 6 gives me 6. This means it's growing 6 times as fast. So I'm going to do 6 times m. Okay, so 6 times m, 6 times 1 would be 6, but I get 7. I already know that it's growing at a rate of 6 times faster than the output. Than the input, I mean. So, if that's growing by 6 times as fast, 6 times 1 is 6. So what do I need to do to 6 to get 7? Add 1. Let's see what happens here. 2 times 6 plus 1 gives me 13. 4 times 6 is 24. Plus 1 gives me 25. 5 times 6 plus 1 gives me 31. So here, there's a little bit of both. So on this one, it's 6 times the output, or times the input plus 1. To get the output. Okay, this is what we call the rate of change. This is how much it's changing. So let's do a couple more. Okay, skip another line here. And let's do N and P. N being my input, at P being my output. So let's say N is 1, and my output is 6. Let's say my output is 10. Let's do 4, and my output is 18. And let's do 6, and my output is 26. Okay. So you're looking at what we do to our input to get our output. First, see if it's just adding. Plus 5. That's not plus 5. That's not plus 5, so it's not just adding. Let's see if it's multiplying. Times 6 would give me here. 2 times 6 is 12. 4 times 6 is 24, so that's not working. So it's probably a combination. So let's see how much it's changing. So if this one changes by 1, this one is changing by 4. As this one changes by 2, this one goes up 8. As this one changes by 2, this one goes up 8. Okay, so let's see how much faster it's changing. What do I do? I want to get 4 times by 4. 2 times 4 is 8. 2 times 4 is 8. All right. This is being multiplied by 4. So it's going to be 4 times the input. But that isn't just enough, because this times 4 does not give me 6. 1 times 4 is 4. Plus what gives me 6? Plus 2, let's see if that works here. 2 times 4 is 8. Plus 2 is 10. 4 times 4 is 16. Plus 2 is 18. Okay, it's working for each one of these. So they're timesing by 4 and then plus 2. And that's giving us our output. Okay, let's skip 2 lines again. Let's try another one like that. Let's just do X and Y again. Alright. If I have an input of 1, I get 2. If I have an input of 2, I get 5. If I have an input of 4, I get 11. If I have an input of 7, I get 20. Alright, let's see what we can figure out here. So we're going to do something to our input to get our output. If I do this, this would just be plus 1. Well, this is obviously not just plus 1, so it's not just adding. Times 2, 2 times 2, nope, times 2, nope, times 2, nope. Okay, so that doesn't work. So now we got to look at how much it changes between each one. So from here to here, it went up 1. From here to here, it went up 3. From here to here, it went up 2. From here to here, it went up 6. From here to here, it went up 3. From here to here, it went up 9. Okay, let's see what we can figure out here. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. Okay, so it's being multiplied by 3. So it's 3 times the input But let's see if that's it. 3 times 1 is 3. What can I do to 3 to get 2? Well, minus 1. Let's try this. 2 times 3 is 6. Minus 1. That would give me 5. 4 times 3 is 12. Minus 1 is 11. 7 times 3 is 21. Minus 1 is 20. So each one of these has taken the input and times it by 3. But then we had to adjust it by minusing 1 to get our output. Okay, that's going to be all for your notes today, but that's how you find a function rule.